for this next part of the video, we're just going to go over generating those arrowheads along the spline. So if we go back here just for a second, so from before we calculated this distance x, which is this distance between the arrowheads, and what we're just basically going to do is go over a for loop over each number of these splines, and then add that x value, add the x value, create an arrow, add the x value, create an arrow, and just go along like that, and just create those arrowheads, and then we're going to sample the spline at these distances that we find and use that to get the transform of the spline. So we're going to get the rotation at that point so that these arrows are facing along the tangent, and we're going to get the position and the scale of those points as well. So if we go back into our script, the next thing we're going to do is we're going to write a sequence function out so that we can have our code go from top to bottom and it's a bit more readable. So first part here is getting the dynamic mesh from that component, and we want to save that into a variable so that we can use it later. So I'm going to create that variable. It's called dyn there, and make that a dynamic mesh, and we'll set that equal to this. And then what we're going to do is we're going to keep sampling this array, sampling this spline for different points in this loop, and we're going to add it to an array so that we end up with an array of transforms of all the rotation positions that we want to spawn these arrowheads. And we want to write some more code down below just to add those arrowheads to the mesh, to our dynamic mesh component, and then print that out. So first we're going to clear that array, and we'll make that variable here as transforms. Put that as a transform and an array variable, and we just want to clear that array. So clear array, hook that up, and it's this array we want to clear. Cool. So next part is doing the for loop. So for loop. So the last index of this is just going to be this: how many spline points we're going to need, because we're going to do one arrow on each spline point. So like so, and then as I said before, we're going to use this index value. So if this is 1, we want to be 1 times distance between points along the spline and sample it. When this is 2, we're going to be twice as far down the spline. So we're going to times this by that distance between points new value that we calculated before, and we're going to we also want to involve time here as well. So we're going to get t normalized, and what we're going to do, so if we get back to our drawing here, so for each of these arrows, the arrow is not going to continually go from the start to the end of the spline. It's actually going to go to the end of the spline and then loop back to the first spline point, and then loop back here. And each of these arrows in these areas, they're going to match up and loop perfectly so that it looks like the arrow is going from the start to the end, but they're actually just staying around this area. So the starting point, we're going to offset the arrow point along the spline based on time. So at the start, we want it to be 0 offset, and then by the end of the animation, we want it to be offset by this x value. So we want to set our time that goes from 0 to 1 to a value that goes from 0 to distance between splines, so that we can finally reach this point at the end of the when time equals 0, basically. So we're going to times this by distance between points. Actually, we already had that there. And what this is going to do is, instead of being 0 to 1, which is what this variable is, if we times it by this number, it's going to then, this output's going to go from 0 to this value. So times this by that, and then we're going to add these together as we're using this value as an offset from where we'd put that arrowhead normally without an animation. So that's going to get offset. And then last thing we need to do as well is this point here could be a distance that's greater than the spline length. So we need to wrap this by the spline length, which we can use modulo again. So use as a wrapping and then get the spline length of that spline and just wrap it by that. And then we're done for our distance. So this is the distance here we're going to use for each of the splines as we go through this for loop. And we want to now use this to sample the spline so we can get transform at distance along spline. So we put in a distance and we need a transform. We'll put this in a location, scale, and a rotation, although this rotation is just 0, 0, 0 for each point for some reason. So I'll create another node called get tangent distance along spline, this one here, and use that one spline variable. And then we'll use this as our rotation, but it's not a rotate at the moment, it's just a vector. So I found that using make rod from Z was a good way to get that as a rotator. That's going to make that arrow face the tangent. And then we'll combine this together by making a transform and picking from each. So we get the rotation from there, and the scale is going to be 1 anyway, but we'll add that there, and then we're going to append this to an array. So array add. We'll hook up our power here. So each time we do this loop, we're going to do this add. It's going to be this array. It's going to be this value. So then that's about it. So we're going to keep adding this transform to this array, and it's going to be the elements in this array is going to be equal to the number of spline points. So we have a transform for each arrowhead, and then we're just going to comment all this and call this generate spline points. And then next we go down in our sequence here, and we're going to add that mesh to this dynamic mesh component. So first we need our static mesh, which we'll create here as arrowhead. We don't want that to be an array. We want that to be a static mesh singular. Let's compile that and plug that in here. So if we make our new save that, and then we should have, oh, we didn't make this public. So if we go back here, make this public so we can change it in our editor here, it should, and I should definitely compile. There we go, and arrowhead, plug that in, distance between points, we'll make 1,000 for now. Speed looks okay. Let's go back into our script. And so next thing we're going to do is get that arrowhead asset, and we're going to make this a validated get just in case we haven't set this up. So only if it's valid are we going to continue, and the function we're going to do to add meshes to that dynamic mesh component is going to be append mesh transformed. And as you see here, it takes in an array of transforms which have just set up and populated. So get that, plug that in here. So target mesh is going to be what dynamic mesh we're going to attach it to, and that's going to be what we made a variable from, this dynamic variable here. That's going to be our target mesh, and then the appended mesh is going to be that static mesh that we're getting, but this won't plug in because it needs to be a dynamic mesh object reference. So the way to convert that I found was using copy mesh from static mesh, putting that in between these. Only if it succeeds, we're going into here, and then to dynamic mesh is where we're going to save that mesh. So for now, we'll save it just in this dynamic variable, and then we'll plug that dynamic mesh from that static mesh into this input here. So it's going to be saving into this dynamic variable all these meshes. So if we compile that, it should be ready to go. Compile, and we'll click play here and see what happens. Okay, so our transform is off. Let's just make sure that we, because our distance here, we need to sample from the same distance. And let's play that. And there we go, now that arrowhead's following that spline. I'll just make this a bit longer so we can see what that looks like with more arrows. And there we go, it's following that spline. One issue you'll notice is this stationary cone here, and that's an artifact from this conversion that we've done. So when we copy mesh from static mesh, we're converting static mesh to a dynamic mesh, but we're also keeping this mesh and attaching it to this dynamic variable as well. And there's no transforming on this, so this is just a 0, 0, 0 static mesh that's going to be added, and it's a bit annoying. So what I found worked is allocating a compute mesh, and a compute mesh is just a dynamic variable mesh that just isn't printed to the screen at all. So it'll be hidden until we generate our meshes, and then we'll add this to the dynamic variable, and this will be seen within the viewport, but this won't. So we'll use this as our dynamic mesh just for the copying and the conversion, and then we'll use our normal one for the rest. So we'll save that, compile, and jump back. And something's gone horribly wrong here. So let's stop that. Is valid, success, transform. Oh, the one thing we didn't do is reset our mesh. So the reason why it was printing so much meshes at the moment is because it isn't clearing all the meshes between each frame. So it's just adding it to a frame and accumulating all those meshes over time. So you need a way of clearing the canvas, clearing that object, which is going to be not that one, but reset dynamic mesh, which you don't want a context sensitive reset mesh, dynamic mesh reset, and then we'll set that before we clear that array. And this will be this here. All right, compile that again, and we should now have clearing meshes. Yeah, perfect. So that's good for the first part. In the next part, we'll go over just adding that profile curve and sweep that along to the arrowheads. So stay tuned for that. Thanks for watching.